All right, this next example is a little bit different because we have disproportionation. So this is where the same element goes through redox and, reduction and oxidation. So household bleach contains sodium hypochlorite. Some of the hypochlorite ions disproportionate, so they react with themselves. First of all, hypochlorite is ClO with a -1 charge. And in this reaction, it produces chloride ions, so Cl-, and chlorate ions, which is ClO3 with a -1 charge. Write the balanced redox for disproportionation. So my only reactant here is the ClO-, the hypochlorite. Because it says it's reacting with itself, the easiest way to do this, so that way we can show clearly the oxidation and reduction half reaction, is show one hypochlorite, reacting with another. This way we can see the oxidation and the reduction reaction very clearly. What do we get? Our products, we get chloride and chlorate. So back to our 6 steps. Step 1, balance everything except H. So are the chlorines balanced as of right now? We've got 2 on each side, so that's good. So step 2, we'll go and assign our oxidation numbers. And when we do that, oxygen is -2, so the chlorine here's got to be +1, -2, +1. Chloride is monoatomic, so same as the charge, -1. And then here, if this is -2 for the oxygen, 3 times -2 is -6. Net charge is -1, so the chlorine has to be +5. Now we've got our redox reaction, so we can identify where do we see an increase, where do we see a decrease. So where do you see the oxidation number increase? If we just pick one of these hypochlorites, it doesn't matter. Let's look at this one. It goes from +1 to +5. So this is a lose electron oxidation reaction, where we see a reduction in oxidation number. Chlorine goes from +1 to -1. So this is a gain electron reduction. So that's step 3. Balance the electron. So to go in our oxidation from +1 to +5, select 4 electrons. And to go from +1 to -1, how many electrons do we have to gain? It's 2 electrons. Okay, 2 electrons per chlorine, but we only have 1 chlorine reacting, so it's a total of 2. Here, it's a total of 4. How do I balance these? What do I need to do? I've got 4 and I've got 2, so I'm going to have to multiply my reduction half reaction by 2. So everything in the reduction reaction gets multiplied by 2. This becomes a 2, and this becomes a 2. So my electrons are now balanced. So now I have a total of 4 electrons here. Electrons lost equals electrons gained. So our electrons cancel. We don't include them as part of the redox, the final balanced redox equation. Now we go on to step 5, which is balance the charge. So if we add up the charge on the left side, I have 2 times negative here, gives me 3. On this, I have 2 times -1 is -2, plus another, that's also -3. So in this case, step 5 is done for us, okay? The charge is already balanced. Step 6, balance your H's and your O's by adding water. Do we have to add water to either side of this equation? So our oxygens are balanced and we don't have any hydrogens, so we're done. We don't have to add water to either side. It's balanced. If we wanted to simplify this though, you've got 2 chlorate plus another chlorate. So you could write the simplified version by just showing 3 hypochlorites on the reactant side.